So, hello everyone. My name is Niklas, and I'm part of the Frends development team. If you have any questions during this webcast, feel free to write them in chat, and we'll try to answer them. So, now that Frends 5.3 is out, one of the biggest new features is the cross-platform agent that will run on both Linux and Windows machines. We'll go more into that today. Good to know before this would be something about Kubernetes, possibly Docker and containers. Some parts might be a bit tricky to follow, and there might be some jargon and more deeper knowledge. Okay, so there's multiple different ways a Frends cross-platform agent that can be deployed. For example, it can be directly installed on a Linux machine. It could be a virtual machine or a actual machine. It can be installed or deployed directly on top of Docker, for example, with Docker files or Docker Compose. And for example, on Kubernetes, both in managed, that means in Azure, Amazon, or Google, or self-hosted. And today, we'll be going through how to deploy a standalone Frends agent to a self-hosted Kubernetes running on Docker desktop for Windows. Okay, so we have this demo environment set up for us. And to start with deploying Kubernetes agent, you go to environments. And we have a default or development environment here with agent group that has no agents deployed. Differences from 5.2 is that we have new settings here called a cross-platform that needs to be enabled for to be able to install the Linux agents. And also allow new agents to connect to the agent group automatically. That means that you don't have to create the agent here manually. Instead, you just download the configuration and read through the README and do the deployment, and then the agent will appear here. So now I will go here, download the ready-made configuration for a local standalone single agent. Let's unzip this to desktop. It's the wrong desktop. There. So here we can see the following files. And you should be able to do the deployment pretty well by just reading the README. But now we'll go through what the different files mean and what settings you have to change to get the deployment going. Get the wrong. Finally. Okay. So when we deploy a single agent, we deploy them in a Kubernetes namespace to keep them separated, keep different agent groups separated. And the things that you will need to have installed or prerequisites to get this going on your local machine is Docker for Windows Desktop installed. And you will also need to have your local C drive mounted into Docker for Desktop. Looks like this. So under shared drives, you have to have C or whatever you choose mounted here. So first step in the README is to create the namespace in Kubernetes. We can just copy the command from here, open our shell, and create the namespace. The next step is optional. If you want HTTPS or API triggers to work with SSL, you have to do this part too, and we're going to do it. If you don't do it, a self-signed certificate will be created on the agent, so you will be able to call SSL endpoints, but you will have to manually go and install the certificate every time the agent restarts. Okay, we have a ready-made. I exported a certificate earlier that you can find here on the desktop, and that has to be moved to the deploy folder under secrets. Next, we have to change the following settings in the deployment files for the deployment to find the correct certificate. So this is the Kubernetes YAML deployment file. A lot of different settings. You can find more info about them under Kubernetes documentation. There are too many to go through now, but I will show which ones you will have to change to get the deployment going. So first, we have to replace all the instances of BFX file name, and our file is called certificate.bfx. Our password here in this demo certificate is as hard as password. And the thumbprint I took earlier already, so I can just paste it in here. I'll change the certificate name. Certificate BFX, yes. Next, there will be another instance of the certificate a bit more down here. This will also we have to change to match the certificate name. For next steps. Oh, there was one step I forgot to make. There is another file here under secrets called app-setting-secrets.json. This is generated by the UI and contains all the information needed for the agent to start working. And here is a certificate thumbprint or path, and we will need to paste the thumbprint we used earlier here. Nothing else has to be changed here, as they are provided correctly directly from the UI. The following settings are about setting memory limits for Kubernetes. In our case, you can see the memory limits here, but they are commented out. They are dependent on what your requirements are. So they are customer by customer. Yeah, they differ from customer to customer. Next, following the README, we will create a local storage class, a volume, and a persistent volume claims for the Frends Agent SQLite database. And that means a persistent volume claim is a Kubernetes node independent claim. And in this location, when this is a Frends single agent, in this location, the SQLite database containing all the information needed for the actual processes in the agent will be stored there. And they will be stored on my local machine. I think we have to do small adjustments in the setting because here are some default settings, but I don't have them here on my machine. I have them under C, French demo. I have to change that. That was the only instance. Yes. And then I have to go to the PVC deploy YAML and do the same thing here. Okay. So if we look at the YAML here, we can see that there are 3 different volume mounts here. One is for the secrets, and that's where the configuration will be passed through. So when the agent starts, it will read the app setting secret JSON through this. Then the 2 others are persisted system and persisted data. Persistent system, we have the processes are stored there, the NuGet packages and the DLLs, and then the SQLite databases. And then we have the persisted data, and if you use the cloud machines, that would compare to the F drive. So it's just a local folder. In my case, it's just a local folder on the machine where I can save process integration data. Okay. Now we can do this part, create the PVC. Yeah, that went through successfully. Computer decided to start updating itself. That's fine. Next, we will create the secrets or pass the secret to Kubernetes. So the secrets were this app settings JSON, so they will be passed to Kubernetes like this. Now they're there. Next, in the README, we basically only have the deploy part left. That will deploy the agent to the Kubernetes node. We have to take a look at the YAML that all the settings are correct. So here we define, for example, the version of the Frends image that we want to deploy. And these are found in our public Docker Hub repository. Just going through. Good. One thing we have to change here, the default ports for HTTP and HTTP triggers are here, but as I already have port 8080 or port 80 and 443 registered, I have to change this to something else. Okay, that should be it. Then we can copy the actual command for the deployment and hope everything works. So at least the command went through. That means that the YAMLs were correct, but that doesn't necessarily mean everything is working yet. So first we can go to the Frends demo effect website. To refresh here. Now the agent should have appeared here. Refresh works. Yeah, so here we can see our newly created Frends Linux agent. And if everything wouldn't have gone correctly, the first step would be to go into the pod, the Kubernetes pod, and check out what went wrong. So we can do that anyway now. This README contains the command to go check the logs. And like that. Now here we got the actual logs from the agent. And here everything went correctly. It created the databases, ran the migrations, got the configuration from the UI. And keeping this log stream open, we can also see like all incoming new errors or warnings that happen, things like that. But we could try to create one process now and see that it actually works. So for example, let's create just a simple process, HTTP trigger. The URL demo, both. And here next we could show you that the persistent data works, so the so-called F drive. So let's do a read file. And the persistent data, you can find it, if I don't remember it, you can find it here. Yeah, so it's just persistent data. So we can put that in the path. And where this will actually read from is here. Oh, that's wrong window again. So here's this Frends demo. These folders were created automatically by Kubernetes. In system, we can see the agent SQLite, things like that. No processes yet, as we haven't deployed any. And in the persistent data, let's create a file here called demo.txt. Add some content there. Hello, Linux. Perfect. What's that? And here we write the rest of the file name, demo.txt. Oh, we actually don't. Where are my scroll bars? No. That's. And we check what this returns. It returns the object and the content. Okay. Process name. Now the process is deployed there, then we can go check. We should see a message here in the agent logs now. Yeah, here we can see that a new process was added to the agent, and that the new trigger was added. So the agent should now be listening on that trigger. We can try it out. And now you can see that we got the response from the agent here. And if we go back to the UI, we can see that one instance was executed. So we got one question in the chat about what database drivers are available, or how can one be added, and how will accessing Windows shares change in Linux Agent. So the new agent is built with .NET Standard or .NET Core, and all the same, or all the APIs supported by .NET Standard are supported by the agent, pretty much. So as long as the Linux agent has access to the Windows share, it will be able to read files and write files there. With access, I mean actual network access. And for the SQL drivers, I quite didn't maybe understand the question, but all the drivers that are under system data, Microsoft should work just fine. For example, we have the Frends SQL task that is already converted .NET Standard, and that works fine. Okay, so now we got our process and run that. Next thing would be what happens if you want to update this local agent. And that happens very easily. We just go to the YAML. In the real world, we would probably have a new version. We would have saved the YAML, and there would be a new Frends version. Then we would just up this version number here and do a new deployment, and that would pretty much update the agent automatically. And because this was a single agent, and here is a replica strategy of recreate, that would mean that there would be a downtime. But with HA agents, there wouldn't be a downtime because Kubernetes automatically handles taking down and putting up the agents again. But now when we want to do an update, we can do it like this. We can add a version label here, and then any string. So we can, for example, put number 1. And now we can go back here, close the log stream. And now we have the same deployment file, the same name, and we just deploy it again. And this means that a new agent was restarted or reinstalled. And check the logs again, so we see that, yeah, it started again. Here we can see I'm still canceling the old one. And soon the new agent should be up again. Should be up. Yeah, here we can see that the agent is back on. And so it's not a very painful process. So biggest differences between this standalone agent and HA is that the standalone agent has its shared state store in a SQLite file, while the HA agent would have it in an SQL database or in an etcd cluster. The HA deployment does contain information on how to set up an etcd, but that is still subject to some change. But we pretty much support any etcd cluster. You only have to give a etcd cluster endpoint to the agent configuration, and then it should automatically connect there. There's this page on the documentation page containing all the different configurations that can be passed into the new Linux or cross-platform agent. And for example, here we can see the shared state, and this could be now your etcd cluster endpoint. Okay. Now we see that when I updated, a new agent got created here, but in a while the old agent the status will go to gray, and then we can delete it if we want to. I think that is pretty much it for this deploying of a standalone Kubernetes agent. If you have any questions, feel free to ask. You can also send them via email to support@frends.com. Okay, thank you very much.